Hey guys, it's Tiny Tom Logan back with another video for you, and today I'm going to finally be giving in and doing an overclocking guide. Now what I will say from the get-go is there is a link underneath to go to a forum thread on my forums at OC3D, and the reason for that is it's far easier for me to be able to help people, or at least even the others really help me because I can't do it all the time, if you do get into any problems. But please follow the video through because all of the answers that you'll have will be in here, for the basics at least, because that's what this is going to be about. We're going to start you from the very beginning, the basics, even setting up your rig at stock. So get yourself a pen and paper and stuff, because obviously you're not going to be able to watch the video when you're in the BIOS. Or you know, maybe get a laptop or your phone or an iPad or something that you can watch this at the same time as working on your rig, because that will help you a fair bit. Now, this is my way of doing things. The thing with overclocking it is it's very, everyone, although we do a similar type of thing, there are, you know, possibilities of different ways to work through stuff. And the way we're trying to do this is structure this to teach you how to do it properly. Because one of the reasons why I've never handed out test results before, or BIOS settings or anything like that, is a thing that everyone needs to get used to, called the silicon lottery. One CPU may do one clock at, you know, X voltage, but another CPU may need more. It may need less. It may not even get to that clock. And it's all about where your CPU come from on the silicon when it was made. The closer it is to the middle from the silicon that it came from, the better clocking, lower voltage, everything that you need. The further that you get to the outside, the lower your clocks drop off and the more your volts go up. Now, we are going to cover quite a lot, and there's many things that I want to explain to you, like why you shouldn't use auto voltage, how bad that can actually be, and the fact that I'm running stock volts doesn't mean you're running stock volts if you've started to overclock. There's many things like this that I want to go through with you, because if you leave your board on auto and start overclocking, your board will actually up the volts for you. But when it ups the volts for you, it will do it much more than it needs to. And there's many things like this that I want to walk you through and show you how to do. Now, what we're going to do to start off with is something that you're probably going to think, why? And what we're going to do is we're going to set the system up at stock, and then we're going to show you what the stock voltage, or the, you know, the stock volts, like the baseline volts are. And then I'm actually going to show you how you can reduce those volts and still keep your system running at stock. But obviously where you reduce the volts, you're going to be reducing temperatures, because most of the heat is caused by volts, which is why when people come to me and go, oh, I've got my CPU at 4.4 gigahertz, what cooler do I need? And it's just like, well, what's the voltage? The voltage is the most critical thing every time. But anyway, so I'm going to show you how you can underclock your CPU, still have it running at stock. And the reason why we do this is if you underclock it, you can find out the volts that your CPU needs to run at stock. Now, I'm going to leave all the turbo and everything on, and I think you will be quite surprised how low we can get the volts on this. We're going to be using, I'll show you the rig, but we're going to be using a 3770K. Now, with all the turbo and everything on, that 3770K will still run at 3.9 gigahertz when loaded up, and we can actually reduce the volts below what they were to start off with. So we'll start with that, but also with the setting up of your rig, what we'll be doing is I'll show you how to set the memory up. I'll explain to you why we'll set the memory slightly lower to start off with, so that we're not going to be stressing the memory controller. I'll show you the volts that you need to, you know, go in and, you know, make sure are set and changed, how to set up your memory timings, all that kind of stuff. So we'll do that first, because then you've got a base to work from, and you know, do I need to be putting volts up beyond this, and do I need to be doing that? And you've also already got all your memory and everything set up ready. So if you hadn't set that up, later on you may get to a point where you think that you need more CPU volts, so you're bagging more CPU volts for, and really it's just because you've not set your memory and stuff up. Also, just as a quick sideline, setting your memory timings up, setting the memory voltage up, in a lot of games, and you wouldn't believe, you wouldn't. I've been shocked how many times this has been right. But sometimes with games, if you start to get stuttering, people think it can be drivers or the game. Go into your BIOS, set the memory up, go back in and play, and it'll play right as ninepence. It's a bit of a weird one, but it happens far too much now. And generally when people say they're having game stuttering problems, that's the first thing I tell them to do. But anyway, what we'll do, I'll show you the rig that we're using to base this all on. I've gone for mainstream Z77 and a 3770K, but you can obviously use these the basics of this to be able to do any other sockets. But if you are using Z77, then it'll obviously still work for a 3570K, a 2600K, a 2700K, a 2500K. You'll be able to use it for all of those, and just don't look at my volts. You need to be working out your own volts, or if you do take a step up with voltage that I do, don't necessarily expect to be getting the same clock that I will, because you may not get there, but you also may get more, again, because of that silicon lottery. But what I'll do is I'll bring you in, we'll talk about the rig. What did I do with my remote? I think it's in my pocket. I'll talk to you about the rig, I'll show you the basic rig that we're going to be using today, and then we'll move on and we'll get into the BIOS. Okie dokie, the rig we are using today is based on a Gigabyte Z77 UP4. It's not a high-end Gigabyte board, but at the same time it's not a low-end one either. It's quite mainstream, middle of the road, which is why we've chosen it. And then we've got a Club 3D 7970 Royal Ace, although to be fair, the GPU isn't going to come into any of it today, and we technically could have done this running off of the onboard video. It wouldn't have made a blind bit of difference. CPU is a 3970K. Now it's worth pointing out that is a retail sample. In the written review, which I've also linked to underneath that Brian did, he's using an engineering sample, and the engineering sample seems to have a much lower voltage requirement than the retails, but nevertheless that's what we're using. So this is going to be the one. It's got the horrible thermal paste between the heatsink, as in on the CPU. So we'll be getting, in the video side of things, we'll be getting results very, very similar to what you can expect. Then we've also got a Corsair H100. We've got the SP120 fans on there. They are the performance edition ones, but I've got fan speed reducers in them. I'm just using those because, well, to be fair, I've got so many of them left over from the crazy Corsair video that I did. So we're using those, and then we've got 8 GB of Corsair Dominator Platinum. Now that's only 2133 megahertz, so again it's middle of the road, but I will show you how to set all that up. I'm not going to show you how to overclock past that point, because from my opinion I think that with the Z77 you should buy the memory speed that you want and then kind of work to it, again because you never know how far your memory sticks are going to go, and the memory overclocking on these boards is very limited. It's more huge steps, but we'll get to that later. So what we'll do now is we need to move on. I need to get into the BIOS on the rig, and then we will go from there. Right, so I've just pressed power on the rig, and all you have to do to get into the BIOS is hit delete. I normally wait until the lights on my keyboard light up, and as soon as they light up I start hitting delete. If you do get problems with your specific motherboard getting into the BIOS, what I would say is sometimes an old PS2 keyboard, and I don't mean PlayStation, I mean the old PS2 port with that circle with the pins inside, can often be a great way to get into your BIOS quickly. Especially with some of the slightly older boards like P67 and stuff. All of the kind of old school kind of pro overclockers, you'll all see that generally they've got an ancient PS2 knackered keyboard with them. As long as the numbers work and the up, down, left, right works and the delete key works, they don't really give a monkeys. But right, into the BIOS. Now we're obviously going to be basing this on the Gigabyte board, so we're going to be basing it on the Gigabyte BIOS. Most of the things with your board will be the same. Say for instance you've got an Asus board or something like that, most of the things will be called the same thing. but you should be able to work out, if there is a slightly different name, you should be able to work out what it's called. Now, I have already loaded up, if you have a look down here, optimized defaults. I did that before and then rebooted. But if you want to go in and just make sure that you're not running any other settings or anything and it is at complete stock, that would be a good start. Now, first thing to go down to is frequency settings. What we're doing now is we're going to set this up at stock and then set our memory up as well. So if we come down here into advanced CPU core features, we can leave everything in there on auto. The main reason for that being is we're not really touching anything. We don't want to overclock that or anything like that. So we will cover, you know, more into this later. And we don't need to touch, we won't touch the memory in here because we're going to go into the actual advanced memory settings and do it. You can use the XMP, and the XMP is a way that you can go in and it's pre-saved memory settings on the RAM sticks, and then it'll auto load it into your system. I always do this manually though because it's so simple. Now if we go down to system memory multiplier, you can see it's on 13.33 at the moment, which is auto. And on your keyboard, over near your number pad, you can just press plus and you'll see it starts to go up. Now the first one is 800 megahertz, which is 8 times. But if we go up, we can click through. And what we're going to do is we're going to set ours to 1600 megahertz. I know the memory's more, but later on what we'll do is we want to make sure when we start overclocking that we're not stressing the memory controller too much. So what we do is we set it at this nice happy point, which we know that the system will run perfectly fine. We know the memory's going to be 100% happy with it. Then we'll get our CPU overclock stable, and then we'll come back later and bump the memory overclocking up. So essentially, if we get any instability by keeping the memory low, we know it's not that. So it's just ruling something out straight away. Something I always will say is if you're going to be pushing your overclocks high, for the performance enhance, I would actually turn that down to normal or disable it altogether. You don't really need it. DRAM timing selectable. What we'll do is I'll put this on quick because you don't need it on expert. There's going to be far too many settings there for most people. Even when I broke the 990FX world record, I didn't go in and do, you know, gazillions of timing settings. But if we go into channel A timing settings there, we can see that we've got some options here. Now, when you buy your memory sticks or looking on the side of your memory sticks, you'll see there's a selection of numbers. You may see 99924. I know the kit that I'm using is 9, 10, 11, 30, and then the command rate is 1. So I'm going to put that in. And then the command rate down here will either probably be a 1 or a 2. Most of them nowadays are 1. If we come down here, you can see it's on auto, but we can also put that in. Now, like I said, for your memory kit, all you need to do is either look on the side of the stick, look on the packet, or have a quick look on their website to see what your timing should be. And it's always worth putting the timings in. I know we're running it lower at the moment, but we are going to up it to its standard rate later. And by having this set, it means that the board can't put them up and down as it so wishes. So we've done that. So we can come out, and then we've got, yep, right, okay, so we're good there. We've done that. We're set up for 1600. Advanced voltage settings. The only thing here at the moment I would say is to go into 3D power control and look for load line calibration. This will be in a completely different place on a lot of other boards, but with the Gigabyte boards, the load line calibration, just stick it on extreme. There is no, it's either off or on really. And what load line calibration does is when you load the CPU up, sometimes you'll see when we open CPU-Z later that the V core will look like it's dropping. The load line calibration helps level that out, so it means that your CPU stays at a relatively constant voltage point, which when you start putting it under load, you don't want it to instantly be running less voltage because it means you have to, you know, you're up your voltage past it. So the load line calibration just helps level everything out. And we're just going to set this here now. I know we're not overclocking yet, but then it's done and dusted. And even on a stock rig, it doesn't hurt to have your load line calibration set up because again, it will, you know, dance around all over the place otherwise. The other thing that we need to do is the CPU V-core voltage control. We'll do that in a sec, but we need to do the DRAM voltage. Now I know my memory is 1.5 volts, so you can go in and manually set that. You might have some 1.35 volt RAM, yours might be 1.65 volts. Just look it up and then just stick that in. You can ignore the rest of them. Now, CPU core, as you can see here, 1.18 volts, so 1.180, enter. That is our stock voltage. Now, we've put it in, but later on you'll see if we had overclocked it could have, you know, bumped it up for us. But now we've done that, it can't go up any further, so that's that done. What we're looking to do now is undervolt. Now what I would say is work down in stages, don't just take a big jump. I've already put the effort in and I know what my CPU will run at minimum, but what I would say for you to work through, which is what I did, is I would, for start off from this, go down to 1.1 volt. Boot into Windows and do a stability test. I'll explain to you in a sec what they are, because I'm going to show you what they are. If it's stable at 1.1 volts, go a little bit further down. Run your test again. Maybe, you know, go down again. Now I know mine will run at this, which is a fair old whack lower. But what I will do now, I need to get the mouse over here. What we'll do now is the way to get out of your BIOS is you hit F10 and it will bring up the save and exit, and then all you need to do is hit enter, and that's saved your BIOS settings now and the system will boot. Now I'll run you through the boot as well. You can see it will start up. This bit always gets me because it makes me think the system's crashed, but it hasn't. On other systems it would have been. So right, we're into Windows. Now I'm going to put links underneath. There are two things that you need to download: CPU-Z and OCCT. You can use Prime 95 if you want, but if you use Prime 95 you also need CPU ID or hardware monitor. Now if we open CPU-Z, essentially what we've done, as you can see here, 1.044 volts. And you can see that the speed will move up and down a little bit, and that's because we've left all the settings where it can turn the voltage down and everything alone. But we'll move that over here, and then what we'll do is we'll open OCCT. Now this is our benchmark program, or rather stress test program, that's a better way of putting it. Now the reason why I like this is because you can see all your voltages, you've got your temperatures, you can see what your frequency is doing, your load, it's got it all in there for you. It's actually a really, really handy tool. Now up on this top corner, what you want to do is go to CPU Lim Pack, Infinite, and then set it up as I've done here. But to be fair, all I would say is the idle period, turn that to 0 because then it goes straight on. Set it up for 90% free memory. Because what it will do is it will load the CPU up to 100%, but also it will load and it will use 90% of your memory as well. So it'll not only be testing the CPU, but it's testing the memory controller and the RAM as well. So it's a great way of, you know, making sure everything's stable. And what we do, we put this just up here so that we can see. You can see that voltage has gone down a bit. There we go. As soon as we hit to put it onto load, then you can see it went up from 1.044 to 1.056, and that's just the load line calibration, making sure that everything stays nice and stable. Now I'm not going to bore you by letting you watch this for ages, but I'm now going to let this run for 30 minutes just to prove to you. Now if we look over here, we can see because of the turbo that we're actually running 3.9 gigahertz here at 1.056 volts. So this is what we'll call our baseline stock voltage. As long as this is stable, I've already tested it, I know it is. This is our base volts that we can run everything that's stock from. So we know that when we overclock, from the here on in, we know this is the point that we need to push our volts up from. So this is why I said set your system up at stock to start off with, and then move on from there. But also, Another thing to consider is, even if you want to set you just want to run your system at stock, you don't want to overclock, or you've got a CPU that can't overclock, you can follow all of the points that we have so far just to make sure that your system is set up correctly. So it's quite a handy bit. This first bit pretty much applies to everyone. It's what we do from this point onwards that, you know, becomes overclocking really. But anyway, I'm going to let this run now for 30 minutes. 30 minutes is a good kind of you know, baseline score, just to make sure that it is stable. When you want to make sure it is 24/7 stable, you will need to run this a lot longer. But for our testing at the moment, and just, you know, make sure it's getting done and it's going to be working, we'll let it run through. We have obviously got a lot of CPU cooling available, because we've got, you know, pretty good fans on an Epic cooler. Now, the test results here, you can see that we've got the maximum scores. We've got 48, 48, 52, 51. At this kind of temperature, it's at this kind of clock, it's more where the CPU not dissipating the heat properly at this kind of low temperature than the cooler. At these kind of low volts, most CPUs will keep, you know, everything relatively happy, and way below 60 degrees. The only reason why the temperatures are dropped here is it's actually cycling through different portions of the benchmark or the test, and different segments of the test will put more heat on it, which is one of the reasons why when I test CPU heatsinks, I run them for 30 minutes at load, so that we get plenty of chances of the hot section. I think they do it in like 2-minute segments or something, 3-minute maybe, I don't know. But anyway, I will leave this running now, and I will come back to you when it's finished, and we'll go from there. Okay then, so we've gone well over on time, but you can see that we've been running for 14 minutes here, and we're still 100% stable. One thing I did forget to tell you was I have set OCCT. If I just turn this off quickly, it does come up with a load of graphs, so you can go in and check everything. But in OCCT, what I'm going to do actually is I'm going to change it to 80 like we do on the CPU heatsink tests, and basically by changing these numbers here, if your system hits 80 degrees, it will stop the test, which will obviously drop all the temperatures and everything back down again to normal. But anyway, so we've done that, we've passed that. What I'm going to do now is, I'm not going to bore you, I'm going to turn the rig off, get back into the BIOS, and I'll show you what we need to do from there on in. Okay then peeps, we're back in the BIOS. Now, we've obviously got our settings saved from before, but what we need to do now is we need to start thinking about overclocking. And I'll tell you what we'll do the voltage first. What you want to do is you want to put your voltage up in stages, and then get to a point where you know everything is, you'll find an unstable point, and then you can up the voltage a bit more again. So what we're going to do is we're going to start at what would have been our stock volts. And this is quite a big step. You can just put it up to 1.1 volts if you want. In fact, I would probably say go to 1.1 volts, find out where you're stable, and then start working your way up. In fact, we'll do that. We'll go to 1.1 volt. Okay, so we've put that in. Now, this is where my way of overclocking may differ from everybody else. Now, with the ASUS overclocking thing, you can disable turbo altogether, and just set this. With the Gigabyte ones, it's a little bit different. I think Brian, when he did the UD5, he was okay. Now, turbo power limit, you can put this up to its maximum and it won't make any difference. It just means that it's available to it should it need it. Core current limit, maximum there is 300 as well, so we can smash those in. We want to leave CPU core enabled alone because we want all 4 to be there. Hyper-threading we want to leave alone. But we want to disable all of the others. CPU IST allows the voltage to go up and down. Thermal monitor, we've got that covered in OCCT, so we don't need to worry about that. If you have thermal monitor on and it gets too hot, think it's just over 70 degrees, it will start to downclock everything. So we want everything to stay okay. And obviously when you really start pushing the clocks, you don't need this stuff on anyway. C1E again is just so that it can reduce the core clock and the VID. But anyway, we go up to Intel Turbo Boost. What we want to do is we want to enable that. Now what you want to do is the turbo, we want all the same. This, like I said, this is just the way I'm showing you how to do it. And the CPU clock, we want all the same. Now we know that it was before at 1.05 volts, it was okay at 3.9 gigahertz. So we've upped it a little bit. So we'll try everything at 4 gig. So we've got that set at 4 gigahertz. So we've just changed that. We've changed our voltage up to 1.1, and really at this point there's nothing else that we really need to touch. So we'll just F10 again and go into Windows. Thankfully, with it being Z77 and we've got a solid state drive on, it doesn't take long to it to boot. Always does look like it's frozen, but you don't need to worry. Just where it's booting up so quick. Right, okay. As I said before, you need to have downloaded OCCT, CPU-Z, maybe Prime 95 and hardware monitor. But what we do, first things first, is we open CPU-Z. And the reason why we do that is we check everything straight away. So 40 multiplier, we know that's right, that gives us 4 gigahertz. And then we also go up here and check our vCore. We can also check the vCore when we start running the test as well, because you'll see whether it goes up and down. That's the reason why we monitor that, is to check VDroop, because if you load it up without load line calibration on, that number will drop, and that just means that you need to turn your load line calibration up more. So we've got that in. CPU LIN pack, AVX capable LIN pack, and then we can go on. And essentially what we want to do now is we're back to testing. We want to make sure that at these volts 4 gigahertz is stable. So I'm now going to let that run for at least 30 minutes. And in the mid clocks, that's around the right sort of time. When you get to wanting to check stability, an hour plus is a great time. When I was testing Orca, I got it, you know, I overclocked it, got it stable, and then I was running the tests overnight to make sure that we're 100% stable. It took me a couple of evenings of making sure everything was completely dialed in. Now one thing you can see is that our temperatures have gone up a little bit already. We've got 50, 51, 55, 55. Obviously we've put the vCore up. We've also put the core speed up as well. But what we'll do is, like I said, I'm going to let this now run for 30 minutes and then I'll come back and I will show you what the next step is that we need to do. Okay then peeps, so as we can see, 33 minutes in, 4 gigahertz at 1.1 volts is, you know, it's near as damn as stable as we can say it's going to be after this long anyway. So what I'm going to do now is I'm just going to nip into the BIOS. I'm going to up the clock to 4.2 gigahertz. So I'm just going to put the multi up to 42 on all the points that we changed before. And then I won't show you that, but I'll bring you back in when we're back into Windows with this open, ready to go again. Okay peeps, so I've got everything set up. Over here you can see, over on CPU-Z, 42 on the multiplier, 4.2 gigahertz there. Volts are still the same, 1.1. Over in OCCT, I've clicked AVX. AVX compatible LIN pack puts a lot more stress and will make the temperatures higher, which is, do you know what I mean? We're trying to stress it out as much as possible. So we'll hit go on this. I honestly don't know at 1.1 volts what's stable. I know what's stable at 1.2 and I know what's stable at 1.3. But I just wanted to kind of run through this so we can, you know, up things slowly. And there we go. It's testing at 100%. Again, I'm now going to leave this for another 30 minutes to see how far it will go on this, and then I will check back with you when it's finished. And well, to be fair guys, this is the way to kind of, it may seem long-winded, but this is the way to do it properly, because you need to learn your system. So this is a really good grounded way to work your way through it. But yes, I will be back in 30 minutes time, and if you keep an eye on the clock down here, you can see that I am doing all this in real time for you as well. I'm literally just turning the camera off, going back to my desk, carrying on with my other work, and then I'll come back to this in 30 minutes when it's finished benching, stress testing, whatever you want to call it. Yet again, 30 minutes in, we're still stable. 1.1 volts, 4.2 gigahertz. So what I'm going to do is I'm going to end the test. I'm going to shut the rig down, go into BIOS, and I'm going to up it to 4.4 gigahertz this time, and then I'll bring you back once we're back in Windows. Okay then peeps, I've tried 4.4 and it wouldn't boot at all. We're now back to 4.3 and we've got like a boot cycle, and you can see it's crashing. So we know we've got to a limit now where 1.1 volts isn't enough, and this is a good thing. This is why I wanted to show you. So we know it's not booting now, so what we'll do is I'm just going to hard turn it off. So we've done that. Going to go back into the BIOS. Right, so we're in the BIOS. Now, just to show you the frequency, I am trying to set it up at 4.3, so we'll do this one first. So I can see that this is where you get the step-by-step bit. So we go into the voltage, core voltage. We know that 1.1 volt doesn't work. So what I would say, it's got to 1.25. Now you always need to remember that the minimum voltage that you can possibly get for the clock that you want is what you want. So if 1.25 works and you want 4.3 gigahertz, you can then try and edge the volts back a little bit, because it may only need 1.2, may only need 1.15. But we'll go up to 1.25, F10 out and save, and we'll go to see if we can get to Windows this time. And this is where it gets confusing. Is it going to? Yes. Right. So again, first thing we need to do is open CPU-Z. .3, 1.128. So the reason why it's gone up above 1.125 is the load line calibration. So we put that up there, click AVX, compatible limb pack again, and then we hit it on, and we'll see how far we get. Now I don't know whether this will be stable or not. It may well be, it may not be, but we'll give it a crack. Yeah, we're up to 90% RAM usage now. You can see a nice big step up in the temperatures. And I'm now going to let this benchmark. You may think, you know what I mean, you want to take a big leap forward. Oh, there we go. Good job I left the camera running. So it's gone off already. Now I'm going to hard turn this off because I want to up the volts, because we know it's not right. Right, so voltage again, CPU core, we'll go up to 1.15 this time. Now you may just think to yourself, oh, I know I'm going to want to get this clock, so I'm just going to, you know, do it the quick way. But you won't learn your system. You need to learn how you know, what clocks your rig needs what for. It makes things much easier for you in the future when it comes to fault finding stuff. Right, so we'll try again. Right, so now you can see our temperatures are now for the first time going into the 60s. It's critical that you keep an eye on your temperatures as well, because obviously I'm using quite a good cooler here. If you're using, you know, a slightly cheaper one, you know, whatever, your temperatures are critical. You don't want them to go too high. Plus, once they get too hot, it will start to become unstable anyway. So right, what I'm going to do is I'm going to let this run now. We'll see how it gets on. If it passes the 30-minute test, I will be back in a sec. Okey-dokey then, peeps. An hour and 8 minutes. Well, this test fell over my lunchtime. I had a lovely jacket potato with chicken, dry chicken tikka, and then it had a natural yogurt and mint sauce. Oh, it's lovely. Absolutely loved it. Anyway, enough about my eating habits. As you can see, it's passed, no problems whatsoever here. Now what I'm going to do is I'm now going to go into the BIOS. I'm going to put the volts up to 1.2 volts, and then I'm going to bump it up to 4.4 gigahertz, and we'll see if that's stable. So yeah, we will. I'm just going to nip in there now, do that quickly, and then we'll come back and we'll, you know, do all this testing and everything again and see how we get on. Okie dokie then, peeps. If you look over on CPU-Z, you can see I've put it up to 1.2 volts. We're at 4.4 gigahertz, so it's just a 44 multiplier. Now I know this for my chip is 100% stable, but we'll show you this. And one of the things I'm going to do is I'm going to show you this is stable at 1.2 volts. And then afterwards what we'll do is I'll then go into the BIOS and I'll set the voltage, the CPU voltage, back to auto, and then you can see how crazy different it can be. Technically 4.4 gigahertz, we're just a smidgen over what was stock volts, because stock was 1.18. So at 1.2 here, we've got almost half a gig extra on top. Well, it is half a gig extra on top of the turbo, but almost a whole gig on top of the actual stock 3.5 gigahertz stock speed for the CPU. And as you can see with the temperatures here, we've got one core which is going up to 66, 67 at the moment, but the rest of them are hovering at, well, we've got 62, 67, 62, 61. So most of them are hovering around the 62 degrees mark, apart from one. We generally do have one hot core anyway, no matter what cooler we use or how many times you try and mount it. It just seems to be the way it is nowadays. But like I said, I'm going to let this run now, give it another 30 minutes. Then I will come back and I'll show you those two things with the auto difference, just so that I can properly, you know, prove to you how much difference it can make when you set it up properly. Okay then, peeps, we can see that we are 100% stable at 4.4 gigahertz at 1.2 volts. 35 minutes in, it's we're happy with this for the way this is, but the one thing I did want to show you is to explain why using auto volts is pretty bad. So what I'm going to do is we're just going to end OCCT, and I want to do this all on camera with you so that you can see exactly what I change. So all I'm going to do is go into the BIOS. I need to lean across, start the rig again. Just going to get it into the BIOS. Right, down to voltage settings, CPU voltage, and all I'm going to change is this. So I've just put it back to auto. Now, Auto doesn't mean that it's going to go back to 1.18 volts. Auto means that it's now going to set itself to do whatever it wants, and where we're running an overclock, it will set the voltage to what it thinks it needs. So I've just F10'd out, saved, and we're going to Windows. Now remember, before we were 100% stable at 1.2 volts. So we just got into Windows, open it, and there we go. We've got 1.416 flicking up to 1.428. So almost 1.43 volts. So that's 0.23 volts above what we know is actually required. And to show you kind of a difference that this would make on temps, I don't even really want to run it this high, to be fair. Right, there we go. As we can see, we're already up. One of the cores 80, 82. There we go. In 20 seconds, it's failed our maximum heat threshold test. Whereas before, like I said, we'd been running it for ages. It was hardly hitting 70 degrees. So this is why you don't use auto volts. You always manually set it, and you work out your clocks and your voltages and everything yourself. You're much, much better off. This is one of the, probably the most important thing that I could have showed you in this video. But anyway, what we're going to do is I've showed you the basics. I'm now going to we'll move into like a conclusion type thing where I'll run over the points that you need to remember and everything, and then yeah, hopefully you'll find this guide useful. Okay, joke then, peeps. So this, just to reiterate, this is just a basic guide. This is just my way of trying to teach you how you can overclock your own rig. Please remember, when you're working through this, don't just copy what I'm doing. Always try and see if you can knock your volts back a little bit. Maybe you'll be able to overclock a little bit further, and you can follow these guides to move the move past the 4.4 gigahertz point and go for 4, 6, 4, 8, you know, 5, whatever you want. The thing to remember is the reason why I've kept the volts really low on this is I don't want to push my chip to its limits. I want you to, now you know the basics, you can use these basics to find the maximum in your own chip. The only thing that you need to do is be critical about the volts and the temperatures. The more you put the volts up, the more your temperatures will go up. So I don't want to be saying to you, for argument's sake, you know, stick X volts in and go from there, because if your cooler's not good enough, you're not going to be able to. You need to balance the two out. The thing about overclocking is you are always going to create more heat, and you have to get rid of that heat to be able to keep things stable. For temperatures, I would say personally, have an absolute upper limit of 80 degrees, and I mean absolute ball aching top. Just don't go above it, which is why I set OCCT to fail at 80 degrees. Something to bear in mind as well was now it was a lot of volts, but 1.4 volts on this CPU, even though the clock was low, and it's a H100i as well, it still failed the test. And it's not a cooler problem, it's just the fact that the CPU just gets extremely hot with that much volts going through it. So you do, you know, still have to go really careful. Now, Intel say 1.35 volts for an Ivy Bridge CPU, but you're going to need a bloody good cooler to keep it cool at that. I have gone past that point, but like I said, you have to, you know, really have just amazing cooling, really, because the more you do put those the volts up, the more it's going to kick in. So what I would do is I would just go step by step, tiny little steps, work your way up, work your voltage up, work your clock up to get, you know, to your stable point where you're happy with temperatures, but you're also happy with the volts that are going through. Now, to put it into kind of, you know, if you've got water cooling and that kind of stuff, you could go up to kind of like 1.4 volts and be relatively stable. But something I will say, and it's something I do have to stress, the more volts you put through your CPU, you are going to reduce the lifespan. And 1.4 volts is a hell of a lot of volts for an Ivy bridge. A Sandy bridge, it's still high, but it's not as bad. But I do want to explain something to you now, and this is another reason why I'm saying it at the point when I'm saying about voltages. I've had CPUs before that have, say for argument's sake, been 100% stable at 4.8 gigahertz at X amount of volts. And then when we're reviewing a motherboard, we're obviously trying to get, you know, the maximum possible we can out of that CPU, and we're raging the volts and we're really, really cranking those volts hard to try and go through it. When we've gone back onto the usual bench motherboard, put that CPU back in, the CPU won't, or on occasions hasn't held our safe overclock anymore. Because we've pushed it too far in another review with too much volts, the CPU then has degraded to a degree that our old safe clock that is alright now doesn't work anymore. And it's now I have had it where it didn't matter if I put the volts up, it just would not do that clock anymore. So if you start overclocking the CPUs and really starting to push stuff, that's when you're really going to risk things starting to go, which is why I'm telling you to go step by step up. Don't just rage it up to that, get your clock up to it, because to be fair, it might not last very long. That's another reason why as well that you shouldn't just auto volt, you know, overclock, because you need to manually set it. You can see how much difference it's made when you do it properly. We've hardly increased the volts over standard. We've still got up to 4.4 gigahertz, and that's 100% stable. The only thing we didn't do was the memory. And all you needed to do, because you've manually set the RAM timings, you could have then gone in and changed the memory multiplier up to 2133, and it does work fine. When you start to go above 2133, especially with Ivy Bridge, which is more, you know, I mean, pretty much all the CPUs are capable of 2400 megahertz memory, you do need to, personally, I would say, go in and manually set everything, and it should do 2400 with the other volts on auto. Sometimes you'll need to, sometimes it's called the IMC, which is the internal memory controller. Sometimes that will need a little bit of a tweak upwards with volts. Some call it the VCCSA, that's another memory voltage. Sometimes you need to turn that up. You have to go careful with that as well. It's another one where if you know it's the memory causing the problems, you do those volts in tiny little increments. You don't just kind of whack it up and rage it up. Because it's with 2011 at least, no, it does count for that as well. The VCCSA, I think it's called volts. That's the volt that if you put it up too high can kill your CPU in 30 seconds. And that's obviously when you're properly raging clocks, but it's not, you have to go careful. It's not something you can just smash in. So yes, I've not given you information about everything. I've taught you the basics so that you can now go away with your CPU and start to put these things into practice. Now, I'm not going to be answering any questions beneath the video, because it's just everyone keeps pummeling me with stuff and I can't keep up with it. So what we're doing now is I'm encouraging people to post on the forums, because there's obviously more members on the forums that will be able to help as well. So I will put the forum link underneath this video. So if you've got any questions, go and ask on the forums and we'll help you in that thread. That also helps us, because when people send me messages on YouTube, if I've sent you a couple of replies, I can't see what the replies are anymore. And the amount of messages I get on YouTube, I just haven't got time to keep going back through my sent messages, trying to work out who you are, what I've said, what the questions were. Whereas on the forums, it's all there in a nice big list and it's really easy to see. But if you do have problems, please, when you come to the forums, post your system specs. We need to know your motherboard, your RAM, your CPU, your cooling, what your RAM settings are, what your CPU settings are, vCore, do you know what I mean? Anything that you've changed. The more information you give us, the 9 times out of 10 we'll be able to advise you better. If you don't give us that information, we'll only end up asking for it anyway. So, you know what I mean? I've tried to kind of keep things basic here, because I want you to be able to go away, explore and learn your own system. And that's what overclocking's about. To see what yours has possible. Yours may be a million times better than mine. I know people that have got 5 gig on not much more volts than this, below 1.3 volts. I've seen 5 gig achieved before and it been 100% stable. At the same time, you may not even get these clocks at all. It really does depend on that silicon lottery. But as I've said, I'm going to put the in the link underneath to the actual main written review that Brian's done, Overclock 3D. The links will be there for CPU-Z, for OCCT, hardware monitor and Prime 95. You can use hardware monitor and Prime 95 if you want, but OCCT and CPU-Z is pretty kind of, it's kind of all in one. But sometimes another thing that you need to understand, just to make things even more confusing, sometimes something will be stable in OCCT and then not in Prime, and the opposite way around. So it's worth checking both for a 24/7 clock anyway. And then the thing is especially when you do start to get into this and you start to explore things and push your kit a little bit more, you're getting free performance, but the fact that you actually get to know your rig is brilliant, because I can guarantee you, anyone that overclocks their rig, in a few, 3-4 months time, you will get problems with it. It may need a bit more volts, it may need something backing off, it may need the CPU cooler cleaning because something's starting to get a bit warm now. And unless you learn these basics, you're not going to be able to work it out afterwards, because you'll just be straight back to the person that told you the results. This is why I don't do it, because it doesn't help anyone. But you'll be straight back to that person that gave you the results in the first place, because it's not working anymore, because you don't have a clue what you've done. So hopefully, fingers crossed, you will find this useful. Obviously, we have done it on a Gigabyte board, and we've done it on a, do you know what I mean, a pretty mainstream UP4 as well. I've got the UP7 here, but I didn't use it. I wanted to use it on something, you know, more accessible, you know, cheaper, that kind of thing. And then you can just basically, if you're using like another brand, like an Asus or an MSI or anything like that, you can take the basics from this, because I've only really changed the V-core, the memory timings and stuff like that. You should be able to work it out and still follow through with this. So hopefully you'll find that useful. I know a lot of people are now going to say about 2011, you can follow pretty much these settings, or not the settings per se, but going through the basics and then working with your own clocks and your own voltages, but still in stages. So you'll still need to work the minimum out. You could still step it up slowly. You may need more or less volts, but that's the same as, you know, the silicon lottery thing. But you can still use this guide as a basis for a 2011 clock. When it comes to things like 1366 or 1156, that's very different, because you have to change the base clock then. So this isn't a guide for them. This is just for 1155 and 2011. Also the same with AMD. They overclock differently as well, because you can have base clock changes and stuff like that. Now I know some people are going to say you can change the base clock on these, but it's so limited. I would say don't touch it. It's also why I say don't touch the base clock when you're doing memory clocking. You just need to go in those steps. Again, that's just a personal thing. Playing with the base clock on Sandy Bridge and Ivy Bridge really doesn't bring enough performance to warrant the hassle that you have to go through for it, and there's so limited difference. It's just not worth bothering with for the extra volts that it needs, and you just don't bother. It's something you don't play with. And now I love overclocking, but the only time I would ever be touching base clock would be literally if I was trying to squeeze out the last kind of like couple of megahertz, really pushing my clock for like maybe a competition or to prove a point, to see how good it really was. But when you are doing that, you risk killing it. Simple as. I have knocked out a couple of Sandy Bridge CPUs that way in the past. I've done a 2011 CPU. I killed a 980X that actually went up proper poof, doesn't work. It's a keyring now. Now I'm lucky because obviously I get my CPUs direct from Intel. They just send me my CPUs. So I've been lucky that I've been able to do this. If you do that, that's a massive dent in your pocket. So that's one of the reasons why I've been trying to stress not to, you know, go overboard and go back. Start right from the very beginning and then take those little baby steps upwards. It doesn't matter if it takes a while. You'll learn more and you will get more from it in the long run. So yeah, if you do get problems, go back to the beginning of the video, start again. and work your way through. I promise you, you'll be able to work it out. I've given you all the information that you need. It's only really when you really start to push the clocks that you may start to come into difficulties. But to be fair, do what I said with the memory and keep that low to start off with, and it'll generally only ever come down to V-core and maybe needing to up the chipset voltage, which I'm pretty sure, and this is called the PCH, but it will be the chipset voltage will probably be the only thing that you will need to touch once you start to push those clocks up. But I'm going to leave this here. This has been a video that I've wanted to do for a long time, but I've been really scared about it. To be fair, I'm still really scared about the way people are going to be, you know, putting loads of questions and stuff in the comments, which is why I've said I'm not going to reply down there at all. You're going to have to go to the forums, and that's just so I can really, people that have problems will be able to go to that thread and read through it and see that other people have done the same thing. Because if we've already answered the question twice, we're just going to tell you to go and, you know, rack off and have a look at the stuff. Please read the threads first. Don't just chime straight in. You know what I mean? First post asking the question that 10 other people have asked before. You're not going to get a very nice response. But anyway, I'm going to leave this here. Hopefully you are going to find this useful. I hope so, because I've put a bloody long time into it. It was pretty much most of the day yesterday, me, you know, testing and making sure I knew what voltages and everything I could do with this. And then today we've obviously been doing all the testing and videoing. I've done it all in real time as well. It's now nearly 3 o'clock in the afternoon, and I've been working on this since 8 o'clock this morning. But anyway, this is Tiny Tom Logan finally with his 1155/2011 overclocking guide out.